So Yassas Thessaloniki. I do speak a little bit of Greek, so if you're going to talk about me, make sure I'm not next to you, okay? Just letting you know. Thank you for having me back here. I came a couple of years ago. It's a brilliant city, Thessaloniki. The reason I didn't come back last year is because I have a 1-year-old child now, so the baby was born just around the same time, so I couldn't come over here. But yes, lovely to be back. Unfortunately, this year, your weather is exactly the same as ours. I didn't come to Greece to have rain, and we've got the same temperature, but okay. I will still take a picture at the end, though, just so my boss believes I'm actually doing work. I'm not just a tourist. So, how many people here are shopping on Black Friday? Hands up, get it just... All right, okay. How many people here are working in a business that has to deal with Black Friday? A few of you. Okay, cool. Right, so Black Friday for us is the busiest time of the year, so I wanted to write a talk and talk about how we deal with that time. So, introduction to myself, my name is J.Coleman. I actually grew up in Kipro, that's why I speak a bit of Greek. But I'm a senior developer advocate for Loqate. I actually started off my career at IBM for 8 years. I swore to myself I'd stay there 5 years. I only stayed 3 extra years, which was good. But all my friends are still there, and they'll probably be there till they die. But I did manage to escape. I escaped and then went to a company called Sonatype. You will know Sonatype if you use Java. Sonatype run Maven Central, so it's the main artifact repository for Java. Now I work at a company called Loqate, which is part of a bigger company called GBG. GBG does identity fraud solutions. I work on the location side of the business. So that's me. What we're going to talk about today. So I'm going to give you a brief history of where Black Friday came from. Talk about how we're going about closing down data centers, because the company I work for is about 35 years old, so we do have physical on-premise data centers. I'll talk about who Loqate is, because it'll give you a bit of context as to why Black Friday is very, very important to us and why we have to deal with so many transactions. Some of the preparations we go through for Black Friday, the technology that underpins pretty much everything we do, some of the issues we've had in the past around Black Friday and how we resolve them. They weren't DNS issues, just to clarify, like seems to be happening every other day now. It was quite funny, actually, because AWS went down the other week, so all our customers went down, but we run on Google. So we were still running, but our customers weren't. And they kept messaging us saying, no, we're all fine. And yeah. So I'm going to talk a little bit about premium tier networking. If you've not heard of this, this is very, very cool, and it's helping us serve customers in Asia without having to bring data centers online over there. And then some just useful resources at the end and takeaways, etc. So the madness, that is 1 billion requests. Where did Black Friday come from? So, of course, as many things do, it's something the United States gave to us. It's actually been around this term quite a long time. So since 1869, this was actually to refer to a financial crisis in the US and the rest of the world where the price of gold plummeted. So it got coined Black Friday. Retail started using it in the 1950s. This was because when the Americans have their Thanksgiving and they eat lots of food, guess what? Nobody turned up to work the next day. So retailers started calling it Black Friday because all their workforce had disappeared. Then later on, the Philadelphia police used it to describe congestion on the roads, etc. Now, the modern term for Black Friday came around in the 1980s. It was essentially when businesses it's the unofficial start of the business, the Christmas shopping period. And it's essentially when businesses went from being in the red, so making a loss throughout the year, to the black, so making a profit. So that's where Black Friday came from. I'm lucky enough to not have to have ever been in one of these queues. And luckily now, most of us don't have to be because we can do all our shopping online. Now, Black Friday for us, now it's getting to this is from 2023. The next slide has stats for 2024. So 2023, we hit over 1 billion transactions for the first time. Now, of course, this isn't all on one day. Black Friday's now been extended to Black Friday. You've got the weekend, Cyber Monday, etc. But what we were noticing is a huge increase to our APIs on these periods, usually more than 2 times the normal amount. So last year, I think, what were we at? 1.22 billion transactions, so it's increasing every year. Now, funny enough, you probably, oh, that didn't come out very nice, did it? Okay, well, what this chart actually shows you is the EU, Europe, now we serve more Black Friday traffic via the EU in Europe than we do in the US. So again, by judging by all your hands up at the beginning, that's all of us doing our online shopping over this period. Whereas before, this was very much just an American thing. But now it seems to have come over to Europe. And I've done this talk in India, and I looked at the stats in India. India is also the same. So Black Friday traffic is growing exponentially over this period. So what does this mean for us? Well, part of some of the problems we had was having run on-premise data centers. This is what caused some of our problems in the past. So what does the cloud offers us? So imagine this is our on-premise data center here, right? We have to have the capacity all year round, basically for Black Friday, but we're not using most of it all year round, right? We've got to have that capacity to serve our customers at these peak times. So that can be quite costly because obviously you've got to maintain all this hardware, keep it up to date, got to have all this extra hardware. So for us, double the normal hardware we need for what, one weekend of the year? So it didn't make sense. So we started slowly moving everything to the cloud. Bear in mind, we're a 35-year-old company. The location side of the business is probably 30 years old. So there was a lot of stuff to move, a lot of architecture to change. But we started off just moving basically what are our monoliths, moving them onto the clouds. This is great, but as you can still see in the blue, we're still wasting resources, right, with monoliths. Now picking that apart and moving to microservices, we're basically getting more granular control over our services and we're saving money, right? That's the theory anyway. I don't care so much about saving money on the clouds unless you're a project manager or someone in management. Most developers don't care because it's not our money we're saving most of the time. So I like to put the concept into energy, right? The more energy we save on the cloud, the more resources we save on the cloud, we're essentially a lot of the time saving energy. So there's been some talks about the new versions of Java, etc. One of the biggest things I think that these new JDK versions help us with is efficiency. They bring down the cost to not only our businesses in terms of money, but the cost to the planet to run all this stuff. I've done a few talks in the past about energy consumption from data centers, and they predict by 2030 that I think it's 1/3 of all electricity on this planet will be going to data centers. Now, I delivered that talk before Gen AI, so I can imagine it might be a lot higher than that. But yeah, it's a massive, massive cost. So any way we can bring down the resources we use on the cloud, so that might be just scaling down to 0 at times, whether that is, for example, having faster startup times of our services, because when services take a minute, 2 minutes, 3 minutes to come online, that is completely wasted energy and resources. We're not serving our customers, we're not doing anything, and we're burning energy. So if we can get that down to as small as possible and scale down to 0, we can save a lot of money and energy. Now, microservices are great. I've been a very big advocate for microservices for a very long time. My first job at IBM was containerizing the first ever IBM product. So, and with containers, generally, we move to the more container kind of microservice architecture. So I've been a big advocate for a very long time. But they don't always make everything easier, right? So I guess there's a lot of waste with a monolith, but at least they're easier to scale. We've only got to scale one thing. We don't have to worry about all these REST calls to all these different services. They just kind of work. So we've kind of gone through that. Now, moving into this era of the clouds, there's lots of things we have to deal with, probably robustness, observability, etc. right? So again, a lot more things we didn't have to think about just running a monolith. So building cloud-native apps. I love this methodology. I pretty much, if I create any application or do any kind of cloud-native work, this is the methodology I follow. Hands up here, who's heard of the 12-factor methodology? A few of you, amazing. I was actually at a conference in Italy a few weeks ago, and not one person had heard of this, which was quite shocking. But what are the 12 factors? I could do a whole talk on just this. I'm not going to, but I'm going to just go through them. So code base is one, having one code base with different revisions, making sure you track your dependencies, don't put configuration inside your source code, backing services, how you build, release, run, the processes that go behind it, port binding, concurrency, blah, 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 blah. So these, if you follow, then there's obviously big explanations behind all of these. So do Google 12-factor, the 12 factors for cloud native apps. But if you generally follow these factors, you will build a really good cloud native application. Now, with any methodology, of course, there becomes a new one. A few years later, someone realizes they've missed off a few things. So this is the revised 15 factors. This is actually much better. I spent a lot of time, the previous talk that was in here was talking about security, which is one of the things that was missed off the original 12 factors. So I'm going to go through these ones in a little bit more detail. So API first. Who's using OpenAPI? Okay, good. That's a good amount of you. So one of the things when I started at Loqate was I'm trying to build a better developer experience for the customers and the developers that try and use our products. So in the documentation, I ripped out all the documentation, built something new. I wanted to create open API specs. I couldn't do that because our APIs return 200 response code and put the error message in the response rather than returning the right code. So one of the first things I shouted about was doing that. Now, this isn't just easy and useful for your customers. Now, API first generally means, or you can go with API-driven development, kind of like that. It's basically defining, like you do with test-driven development, you define your APIs up front. You define your APIs, you create an open API spec, etc. Now, this is very useful if you're building stuff with a microservice architecture, because what it means is teams can now work in parallel on services that will talk to each other. Because at the end of the day, I already know that the other team, what they're working on, I know what their APIs are expecting and what I will get back from them, which means I can build my service completely independently of the other service, right? So API first is definitely one of the most important ones there. Open telemetry obviously goes without saying, especially in the microservice architecture where we've got all these calls going to different things. Open telemetry is a great thing here. I saw this meme the other day, so security is the next one. The meme basically says, ever since I did a virus scan, all the hot single girls in my area seem to have gone missing, right? Now, I thought this was quite funny. And the irony of this, I'm preaching about security, is I actually got caught on a phishing scam this morning. So my boss was writing some documentation for our SDKs, and I said to him, look, I'm working over the weekends. If you want me to review it, I can review it over the weekend and get back to you on Monday. So I got an email from him Friday night with a PDF in it. Of course, I thought it was a bit weird that he put the documentation in a PDF, not in Markdown, how we normally do it. But I was like, oh, that's fine. I opened it, and then it said, you have been phished. And now I've got security training I have to do next week, which is all good fun. But this is really, really important. I can't believe they missed this off the first 12 factors. But security is really important because nowadays, bad actors are trying to get into our software wherever they can. Now, firewalls and stuff have got very advanced. So now they're doing it using social engineering. They're getting into our dependencies. Who remembers Log4j? I imagine you all remember Log4j. So because I worked at Sonatype and we ran Maven Central, we could see who was downloading what version of what dependency, right? So this was, I think, about 6 months after the Log4j, bear in mind, worst vulnerability in Java's history, came out. Oh, this isn't rendering very well on here. It looks lovely on here, just FYI. 51 million downloads of the worst Java vulnerability in history. If we fast forward another 6 months, do you think that got better? 128 million downloads of the worst vulnerability in history. I know we've all seen this picture before, but this is basically what happens, right? And today, I think still 13% of all downloads of Log4j are still the worst vulnerability in Java's history, right? So it's quite scary. And that's up to us. That's up to us to fix that problem, right? So we've got to be very careful in terms of security, dependencies, and whatever we're doing to make sure our applications are safe. That's why I always start to question AI, because AI doesn't make the safest applications. So if you are using AI to generate code, etc., just keep security in mind no matter what you're doing. I'm going to spare you all from AI today, because I imagine you've probably heard enough AI. But the problem is, if we want to prioritize a certain thing, like startup time, for example, that might have an effect on throughput. So when I worked at IBM in WebSphere, we had a lot of competitors coming up, like you probably heard of Quarkus. There was lots of and GraalVM, etc. Now, these were great because they could start our applications up really, really quickly, right? But then when you compared the throughput of those applications, you basically required 3 times more of the same applications for the same throughput we did with our product. So you've got my point here is, just because something's shiny and new and starts up very quickly, is that really what your business needs, right? It's all to do with your business and what they actually need and what the customers need. So don't just go and try and pick startup time because you think it's really useful, because throughput might be the thing you really care about, right? So how long have we got? Okay, 24 minutes. So who is Loqate? Just to give you context of why Black Friday is very important to us. So Loqate has the biggest address database in the whole world. We have crazy amount of data in our database. So whenever, you can't see this very well, but you know when you start typing your address and it comes up with a load of addresses underneath, these are the recommendations, that is us a lot of the time, okay? So we've got a capture thing, we've got a verify thing, and we also do the same for phone, email, and bank validation. So it's kind of verification and validation tools for addresses and other things. So that is quite important to e-commerce shoppers, as you can imagine. We have some of the biggest e-commerce shops in the world. So making sure that when someone orders something, that address actually exists and their product gets there is very important, because that can be very costly, getting returns and having to reship them again, or you might lose the customer because they're not getting their packages. That's why Black Friday is a bit crazy for us. So there is my little pitch to make my manager happy. Now to talk about the preparations for Black Friday. It was quite funny because when I first started creating this talk, the business was very like, oh, don't talk about the bad things. Don't talk about this. I was like, but that's kind of what people want to know, right? People want to know what you figured out that's going wrong and how you fixed it. That's a good thing for conferences. So we actually start preparing between 1 and 3 months ahead of time. So we've already started preparing for this year's Black Friday quite a while ago. And then we do more preparation in 1 or 2 weeks. And then the final couple of days, everyone's sweating, we're all getting worried, and then it's Black Friday. So like I said, we generally see about double the traffic over Black Friday period. We currently have 3 data centers. We actually now have 4. We turned on a new one Wednesday, which is quite interesting. I'll talk about that a bit later. But what we do, we basically need about 3 capacity on the day, 3 times the capacity on the day. That is because if one of those data centers fails and that traffic has to get shipped to another data center, they have to be able to handle that capacity, right? So it's not just, we're not testing just for, okay, we get double the capacity on that day. We test actually 6 times that capacity, because we want to know that if any of our data centers fall over and the traffic gets rerouted, they have the capacity to handle that. So we do lots of different things. We do a mixture of platform load testing. So that is around throughput and stability of the cloud infrastructure components, such as web servers, load balancers, databases, things like that. Then we move to the product load testing. So this is kind of the throughput and the stability running at 6 times capacity of all of our products, and with the failure of one of the data centers. So platform load testing, this is what we kind of start quite a lot in advance. Now this year, we've changed our approach a little bit. We've been doing this throughout the year. Now we do still run this 1 or 2 months before Black Friday, but we've generally got into a routine of running this throughout the year. Now the reason for that, and don't get me wrong, this is an expensive thing for us to do. It brings up our cloud costs quite a lot, but it means we don't have any nasty surprises and we're all scrambling around just before Black Friday to figure stuff out. So what would I say you should do for platform load testing? I would say what you want to do is identify the APIs that are in scope first, right? Because over Black Friday, not all of our products are in scope. There is no point of us paying a load of money to our cloud providers for stuff that isn't going to have increased capacity over Black Friday. So what I'd say with any platform or load testing, first of all, if you've got a busy period, make sure you identify the products and the APIs and the services that are in scope. Then you want to identify the different loading patterns per region. So for example, like I said at the beginning, Asia is slowly getting more Black Friday traffic, but at the moment, Europe has the most Black Friday traffic. So we create different load profiles depending on the region, depending on what that traffic demands will probably be. I suggest find a baseline. So find kind of like what the peak loads are for each API generally. And that's at your normal capacity, not with the increased capacity you're going to do. Generally start with your staging environment for everything. We test in both. Now, obviously, it can be very scary to test in production, but as with any staging environment, it's never identical to your production environment. So we do test on production just to be 100% sure, which is always very scary because obviously if we break stuff, it can affect our customers. We essentially, to do this testing, we spin up a K6 operator called LoadStorm. I actually thought it was called Store, but I got that information when I was in an airport, so I didn't hear it quickly. But yeah, LoadStorm. We do that with actual external traffic to mimic what it's like in real life. And then we basically eventually scale that up more and more. We don't just hit it all straight away, but what we do is we do it all in WAD pods. That's generally because of cloud port restrictions and stuff like that. So yeah, like I said, we do test in production. There is some important things I would stress if you're testing in production. First being, don't go and hit it with 6 times the load in one go, because you'll break your infrastructure. That's not like real life. You don't get 6 times load like that. So what we do is we ramp up in 5 to 10 minute intervals. And that's generally because, like I said, we're an old company. We've still got quite a lot of monoliths that take a while to start up. So it's a case of we ramp it up slowly to allow all the services to come up, as would generally be the same in real life. We keep it at basically a 51% threshold at all times. So when we see the throughput getting to about 51%, then we'll pause and let it go a bit bigger, etc. Again, do this with staging, but testing in production can be really useful because, again, there's always differences between your staging and production environment. So platform and load testing. This is when we do a final load test. We hit everything or all the in-scope APIs with around 6 times the capacity. We leave that running for about 50 minutes just to make sure everything's okay. Again, this is a very expensive test for us, so you don't want to do it indefinitely. One thing I would suggest is constantly check for memory leaks while you're doing this, because memory leaks can be a good indicator that something will possibly go wrong after the 50 minutes. And then we basically load test the whole platform. So we do this for each individual API, and then we do the same thing for all of the APIs on our platform. The thing is with Google Cloud is, and a lot of cloud providers are the same, is they generally take Google takes around 30 seconds before a problem occurs and they report it to you. So you've got to be very careful. Yes, you can rely on the platform to tell you there's a problem, but there might be a delay. And that 30 seconds can mean an outage. It can mean anything, right? So just be very careful. That's why I'm always monitoring the logs, that it might take up to 30 seconds for your cloud provider, longer or maybe a little bit less, but there will always be a delay before it reports something has gone wrong. So 1 to 2 weeks before Black Friday, we essentially manually scale everything, right? There's reasons for that, but mainly because it gives us peace of mind. Now, we've had it in the past where we've relied on auto-scaling. That hasn't worked very well. Sometimes, again, with delays in reporting and stuff like that, it might not always scale up exactly when you need it. So what we do is, because this is only 4 days of the year, and we know this is very, very important to our customers, most e-commerce businesses, they make a lot of money on this period. We just take the financial hit and we scale everything up manually, right? So that's databases, web servers, things like that. We kind of scaling of non-cloud components, so stuff that's still on the data centers. We kind of only scale that if required. That's even more expensive because it means we've got to find hardware from somewhere to do it. So we only scale that if the tests indicate that that is required. Scaling down, so because it's not just Black Friday and it's not just that weekend, basically e-commerce businesses are making a lot of money all the way up until they've got a lot of traffic until mid-December. Mid-December, most people have bought their Christmas presents, right? And they're doing a lot less shopping. So that's when actual normal shops make some money because everyone's running out to go and get last minute things because they're scared their deliveries won't arrive. So generally around mid-December, that's when we scale stuff down again. One thing I would stress throughout the whole of this is keeping your support team in the loop with all of this. Because your customers, they are going to, when they have a problem, it's your support team that they will message and call first. If they're not in the loop, that is bad customer service because they're going to turn around to our customers and they will not know what's going on essentially, right? So I must stress it's very, very important to keep support in the loop at all times. Now, when we test, we don't do this much anymore because we've got very good at testing in production where our customers notice no difference. But when we first started doing this, we basically would always, I mean, you should tell the support team anyway, but we would basically send a notice to our customers to say, we're doing some maintenance work, something like that. Please be aware, there might be some latency issues or something like that. Nowadays, we've got really good at testing in production, which is fine. But telling your support team is a must as well, because again, if some of our customers have latency issues and some of our customers have their own tooling that are monitoring the latency constantly, you want your support team to have a good answer to those questions. Now, this is when everyone in my department starts sweating, especially the people who run the Google Cloud infrastructure. So essentially what we do 1 or 2 days is we actually do something a bit crazy. We just take down one of our data centers. Now we do this because we can pretty much 99.9% guarantee that if there's a problem now, 1 or 2 days before Black Friday, it'll be the same as it will be on Black Friday. Whereas we can pretty much guarantee that if we notice that we just take down one of our data centers and the traffic gets rerouted to our data centers, in a couple of days' time, that will be replicated. So 1 or 2 days before, we actually take down one of our data centers to make sure all the traffic gets rerouted elsewhere. Bit scary, as you can imagine. So that's one of the things we do 1 or 2 days before. I would say we also disable database maintenance. So don't move house over Black Friday because we won't pick that up. Don't build a new house because that address will not be recorded. We just disable all of our database stuff over that weekend. Basically, my advice would be to defer patching of servers. Now, of course, you've got to weigh up the risk, right? So if a big vulnerability comes into our web servers and it's reachable and external to the outside world, we may have to take the hit and do that update. But generally, unless the risk is really high, we will defer that until after the weekend, so Tuesday, basically. I would say, again, you have to weigh up the risk there, right? And again, going back to what I mentioned before, make sure support is aware. If you're going to take one of your data centers down 2 days before the busiest period of the year, make sure they're aware. So if customers ask them, they know what to say. So we're about, in terms of our architecture, halfway between monoliths and microservices. Again, spent a lot of time in my career talking about microservices. We actually had this monolith, which we said, okay, this is quite old, it's hard to maintain. So what we're going to do, we're going to build it all from scratch, all using lovely microservices. That project lasted about a year, and then we basically stopped working on it and went back to the monolith. And now I've decided we're going to break apart the monolith because rebuilding everything we had was really difficult. And because you can imagine, I'm typing my address, that request has to bounce across the internet and get back to my browser so quickly that it's basically advising other addresses, is that any kind of architectural change that adds any latency between all of our services costs our customer basically its latency at the end. Whereas a monolith, there was very minimal latency between our services because they're all in one application, right? So we're kind of going back to a hybrid approach of trying to do two. So we essentially have a mixture of virtual machines and Kubernetes. This basically is because we've got old legacy stuff, but on top of that, that gives us a lot of different things. So reliability, failover. So if something happens to, say, our Google Cloud Kubernetes cluster, we can revert back to virtual machines and vice versa. So it's quite useful there. We've got some supporting services, so I'll go over some of these in a moment, but Google PubSub has saved us a lot of money and a lot of issues. We use BigQuery, and then we use Google Cloud for monitoring and stuff like that. So Google PubSub, anyone use Google PubSub or something like that? Use a Google kind of queue? Yes, okay, amazing. So this is really good. Reactive architecture is a bit like this, etc. Our biggest use case was basically getting data out of our web boxes asynchronously. basically, if the SQL server had too many requests, it basically caused it to fall over. So what we did is put this kind of queue in front of it, so at no point the SQL servers would get hammered too much and they wouldn't fall over, which was good. It kind of combines scalability of Apache Kafka and Pulsar and other features found in other things as well, but I definitely recommend it. So there was a project we did at IBM where I can't say the customer, but they had a problem. They were, I think you actually have this business here in Greece as well. Big telephone provider, one of the biggest in the world. They have mobile phone networks, etc. Now, they were having a problem when the new iPhone was coming out. So new iPhone was coming out and their websites were getting hammered. They were getting something like 175 visits per that month, 2.5 billion interactions per year. And it was basically their whole website was grinding to a halt whenever a new iPhone came out. Now, the problem is, if I keep going to a website and it's taking 7 seconds to load a page, I'm probably going to start looking elsewhere for the products I need. And they were having a real big problem with this. So essentially, they moved to this kind of reactive architecture, putting queues basically in front of everything. And this basically helps their conversion of buying stuff from 1.9 to 3.1%. Page response times went from nearly 10 seconds down to 2 or 3. Yes, I know we want it to load faster than that, but bear in mind, this is an iPhone release, so a lot of people are doing it. They actually got away with 1/8 of the infrastructure they used before. So this is all very impressive. Now, reactive architecture, if you're coding in that pattern, requires a mindset change. It's not something you can just pick up and start doing. You'll probably have to train your whole engineering team to think in that way, but it can have really great savings in terms of A, helping your business, and B, savings on the cloud, etc. So like I said, we have a mixture of old and new technologies. So we have a free tier web application. This is great. So we have a monolith, our main monolith where all of our services things go through, called services. What a great name for an application, right? So I spent probably the first 3 or 4 months at Loqate trying to figure out what the hell everyone was talking about. Because I'm on all these calls and they're all referring to services. And I obviously presumed services was all of our services. No, it was one application that someone named 20 years ago services. So it took me a while to figure out what the hell everyone was talking about. The problem is we're trying to break up services because at the moment it's kind of a bottleneck for us. All our microservices and all our new services are created in a microservice architecture, but they all essentially get funneled through this one service, stupidly again, called services. So we're trying to break that up a little bit because it's quite a bottleneck in some regards. We use a WebDB, but we're slowly transitioning to Mongo, etc. We, until recently, had 1,200 services running at one time to support our customers. We've got that down to about 400, but yeah, a lot of services. Now, in terms of traffic balancing our data centers, we do it on geolocation. So whatever the lowest latency data center is, that is where the traffic will go, okay? Yes, we do have a 24-year-old service that we are unable to shut down. Can you imagine running a service for 24 years? Now, there is a reason behind this. A lot of our customers are e-commerce businesses. Now, some of them, Stavro, who set up his flower shop, right? He doesn't know how to develop a website, so he would have hired a website designer to do that for him 25 years ago. Now, because basically shutting down that service, basically what we do is we just increase the versions or release new APIs, but that Stavro is not going to be able to go into his website and update that URL and that API, right? So if we turn off that service, we probably will lose those customers forever. So we've got this service and it's still running. It probably will still run forever, who knows? Someone gave me a great idea the other day. It was, how do you get in contact? Because basically their email addresses don't work or their phone numbers don't work anymore. How do you get in contact with a customer like that? Someone gave me a really good idea. Put it on their bank statement. That's a clever idea, right? Just change the reference on the bank statement to say, we're shutting down this service. I bet you then they'll realize and get in contact with you. Never thought about that before. Sorry, excuse me. So, past issues, what we've had to deal with in the past. Again, it's not a DNS issue, as it seems to be the case all the time nowadays. I found it funny because after the AWS incident a few weeks ago, you probably got all the Azure cloud engineer, Azure salesmen going, yeah, this is why you should go to Azure, you know, AWS, all these problems, and then boom, same thing happens to Azure. I saw a really good meme that was this guy going, oh, I've left AWS because they don't get my vibe coding skills, etc. So I've gone to a real company like Microsoft who appreciates vibe coding. I thought that was quite funny. For us, it's generally scaling issues that we've had in the past. There's been a few. We haven't had them in quite a long time. We've essentially addressed this by adding a lot of automation into the web layer side of things. We've tried to allow it to scale itself in most instances, but again, over Black Friday, we do a lot of manual scaling. And we've also tried to do a lot of work to decouple certain elements. So, for example, we added a caching layer, which allow basically us to talk between our web servers and our SQLs, like Google Pubs up. So the last big issue we had was in 2020. On-site data center crashed. I think this was the one in the UK. No, this was the one in America, sorry. So our on-site data center crashed. It's right in the center of America. Of course, that means all the traffic then got rerouted to the next closest data center, which was in Europe. Of course, we had back then very strict firewall limits. So the data centers in Europe basically went, well, we're getting DDoS here, stop receiving requests. But they were actual generally requests. So it basically caused a whole worldwide outage of all our services, which was obviously very frustrating for our customers. So moving to the cloud has helped a lot of this. Obviously, having a better firewall, etc. Having more data centers has helped as well. So the future, what are we planning to do? I've got 3 minutes and 36 seconds. So work to improve scaling. So even though we probably will always manually scale at this time of the year, we have a lot of auto scaling the rest of the year, right? There is lots of different times of the year where all of a sudden there's a sale released at a very big e-commerce customer that causes lots of traffic to us. So throughout the year, we basically removed most of the manually scaling. So we only scale over this period. We've tried to move more services into a microservice architecture where it makes sense and the latency between those services doesn't matter so much. And we put better monitoring and traffic in. So we're using Datadog and lots of other things to monitor traffic all the time and not just solely rely on the cloud providers, which can sometimes be a bit slow. Working to improve resilience. So like I said, we've basically moved to testing every month rather than just 2 or 3 months beforehand. More data centers around the world helps, better capacity spreading of those data centers. And we also looked at one time of using multi-cloud. So as we'd all know, with AWS and Azure, if we were running all these systems on multiple cloud providers and you just switch when one goes down, we would avoid all these outages, right? And invest in platform tools, and maybe a good platform engineer as well. So what's the plan for this year? So currently we have, you can see this on the screen, good. We have a data center in Belgium, one in the UK, and one in the middle of the United States. The problem is we're getting lots and lots of new customers in Asia. Now, it's not a cheap thing to bring online a new data center. It's expensive, requires maintenance. So we have got some workarounds, which I'll talk about in a minute. But essentially, with any kind of thing with technology, there has to be a business case. There has to be a reason for spending that money in that region. So until we've got enough customers over there, it doesn't make sense for us to spin up a data center. But that is the plan, to have one there. And eventually, so what we've just done is this week, we've just opened a new data center on the west coast of the US. We'll eventually move our data center in the middle of the US to the east coast, which gives us much better geolocation. So it means all the requests that come from Asia will hit the west coast and not have to travel through to Central America. And America's not really impacted because I'll have a data center on each thing. Now, this is really cool, and this has helped us a lot. Oh, again, this projector's not showing this very well. But as with traffic around the internet, you essentially have your data center, it leaves your data center, bounces around to the internet until it gets to the end user, right? Google have been very quietly laying internet cables throughout the whole world for years and years, which means they can do this. This is amazing. So rather than your traffic leaving the data center and Google's network where it's running in that data center, it now travels through Google's network and leaves close to the destination. That improves latency a lot. Don't get me wrong, it's not going to take a website that takes 10 seconds to load down to 2 seconds, but it does mean it'll shave a bit of time off, which is basically enough to allow our customers in Asia to use our services and not have latency issues. But like I said, Google has been laying private networks around the whole planet for a very, very long time. They are the biggest producer of private internet networks in the world, followed by Facebook. Amazon and Microsoft are nowhere even close. So it means Google are uniquely positioned to offer this technology where no one else can. All right, I've got 5 seconds. So reducing cloud costs. This has been a byproduct of basically us trying to bring our costs down, but it's also helped with reliability, things like that. So improving startup times, moving from Windows to Linux, things like that. Not only have they reduced our cloud costs, but they've made our services more reliable. So to conclude, capacity testing is key for any busy period you have, and basically don't do it the week before, do it at least a month before, if not throughout the year. I would say if you have a very, very busy time, if you're an e-commerce business, it probably just makes sense to scale up for that period, right? Yes, it will cost us, but it'll cost us a lot more if our customers can't use our services and they don't come back. Like I said, notify users when you're testing stuff, specifically your support team who can talk to your customers, and hire a good platform engineer. We hired a good one 3 or 4 years ago, and he basically rewrote the book. So please do that. And again, automation is key, but not the most important thing over this period. If you want to know more about what we do at Loqate, you can scan that QR code. If you want some of the information from this talk and where I got some of my information from, it's all available in those links. I'm going to go next now. You feel free to get in touch with me. I don't use Twitter as much as I used to, but I'm still on Twitter or LinkedIn. If you want to join our Slack community and learn about anything location-based, feel free to. And with that, I am going to say thank you, and thank you for having me.